Hello everyone, so today we are going to do Leetcode daily challenge, longest string chain. So in this question, we are given with vector of string, and in that vector of string, we are required to basically return the length of the longest string chain which is being formed. Now in this question, the thing is that here, as per this question, let me first tell you about this whole question, what all it is. So we are given with array of words, basically this vector of string which is being given to us. Then some definition is given that word A is predecessor of word B if and only if we can insert exactly one letter anywhere in the word A without changing the order of the other characters. That is, if A is there, then we could make it AB. Now B is one character which is being added. Then we could insert C here. Here the order of A and B is not changed. That is, after A, B is coming. But yeah, relative order, that just after A, B should be there, that has been changed. So that gives us somehow the hint that yes, here something related to subsequence could be happen. Could take place, and then we are given with then we can directly have this T also here. Again, the ordering is now same, only that A comes after that A, there is C, and after that C, B is there, but T is inserted in the middle. So this is the chain which is being formed, and this is the definition which is being given here. And they have also told that a word change is a sequence of words like this, where k is greater than equal to 1, where word 1 is the predecessor of word 2 and word 2 is predecessor of word 3, and so on. A single word is trivially a word chain with k equals to 1. So even if we are given with the single word, then it is also word chain in itself, where k value would be 1. So that is what they want to say. Now we are required to return the length of the longest possible word chain that could be made out of all the words which are being given to us in this vector of string, and with word chosen from the given list. Yeah, basically from that list. That is what they want to say. Before jumping to that question, let us check for the constraints. So the length could be that there could be 1000 words at most, but each word length could be till 16, right? So according to all of this, now here the time complexity could go, rather than just order of n, it could go to order of n square, even n into log n, and then n square into log n, something like that. We can go ahead with the time complexity. So this is what these constraints give us the hint about. So now the next thing is that these words which are given to us. So yeah, this all is there. Now let me first the explanation which I have created, as you can see. So the word which could be formed from A, it could be BA, then BCA, and then BDCA, right? These all could be formed, and even this could have been also formed BA, then BCA. Not this BCA, basically this BDA, that could have been formed, and then this BDCA, because then also the relative order is there. But we are concerned with the answer. In both of the cases, the answer is 4 only. So yeah, at the end 4 would be returned. So here the ordering shouldn't be changed, right? So ordering is not, but relative ordering could be changed, and this gives us the hint of subsequence. Relative ordering in the sense that after A, relative ordering here I meant by that if after A, B is coming, then even after A, C could come. It is not an hard and fast rule that after A, B should be only there, and after that B, C could be there. So basically it is not about the substrings, it's about the subsequence. that we can figure out some subsequence also. That could also work. Moreover, we need to find longest string, right? So here the thing is something like that. We are required to check for a previous answer also which is there, right? So surely there would be sub cases also there. So in all that sense, here it is something related to DP. That yeah, there could be recursive solution, could be DFS also, could be a graphical solution also, because it is also forming a graph. So in all those contexts, it is a question of DFS, or it is also a question of DP, in which we are obliged to store things and then we are required to go ahead. And while storing and checking with our past results, basically past sub cases, that yes, this was the answer of a previous sub case. This is being concerned with the present sub case in due to some specific condition. So yes, this will contribute to our answer. So in that sense, what all I'm saying here. So here we need to find the longest string, right? It could be increasing or it could be decreasing. That is also not our concern. But our only concern is that we are required to find the longest string. So in all both of these points give us hint for LIS. That is the thing here. Because in LIS also, that is the longest increasing subsequence, there also we are given with the increasing, we are required to find the longest subsequence which is increasing in order. Right here also we can find that only. That we are required to find longest increasing chain here. And that chain is in that sense only the way LIS is there. But yeah, we can go ahead with that solution also. Means we can code that solution also. I'll show you that also. But there is one more thing. Okay. But beside LIS solution, this question could be done by other method too, in which time complexity is being reduced than the LIS. If we think this question in terms of graph, where we are subtracting a letter from whole word and checking if that exists in the whole input words vector of string, then we will repeat the same thing for that word until we find no more word which could be found. So this is the main intuition behind that particular solution which we could form rather than going ahead with LIS solution. Although that LIS solution is somehow the most simplified one, but this particular solution is the one where the time complexity is being reduced, because here we won't be requiring any sorting. In LIS, we would be obliged to sort our words according to the length. So that's why in this solution, we would be able to come up with a more lesser time complexity solution. So let's first go ahead with this solution, how this solution would work. So the thing is that here we are given with these, right? So here we won't sort any of them. We'll just pick up from the start itself, right? But here for the simplification, that's how this particular would work, because in this particular solution, there would be application of DFS. So when we perform DFS, then it will do DFS in this context, that if we are given with this A, right? So when there is A, then there is nothing which we could, even if we delete A, right? Then there is nothing, no other word would be left, right? So we are only left with the option that we will add 1 to our unordered mapper set, which we will be taking for easy lookup. Basically, the components of this solution would be that we are required with a set which will consist of all these words which are there, and then we would be having this is hash set basically, and then we would be having hash map. In this, we will store the count and the string. Both of them would be stored. So this one I'll add up to this particular hash map only. Then I'm unable to do DFS on this particular word. Then comes this B, same reason that when we delete this B, then 1 is there, then again I'll add that to map. Now comes the part of this AB. In this AB, I have two options. Either, I won't explain you in context of options, but I can say that, yeah, now I can check by first deleting the first letter, right? Then I'll find that, yeah, now I don't have anything. So at this moment, I'll add 1 to this hash map for this AB. And then I'll check for this AB again, and then B would be deleted, and then I would be having this A. Okay. Wait, let me write it again. So now first I'll delete this A, right? So what we would be left with? B. And then we were storing all these words which are being there, A, B, right, in this particular set, right? So then during the time of the DFS only, now it will check that do this B exist in this particular hash set or not. Yes, it exists, right? And at that particular moment, it will again do DFS, and then when it do DFS, then it will come up to this particular point again, right? And when it comes to this particular point, then it will check that do this particular B really exist in this set. It will check yes, it exists, and then it will check for the value that will be 1 itself, right? Then in this hash map, for a corresponding value to this AB would be 1 plus DFS of this particular B, which will also give us 1. So this AB would be now having 2. So basically, this is the whole logic for this particular question, that we are required to have a lookup in particular hash set that do these elements exist while doing the DFS over that particular word, and then if that word really exists, then what we will be doing is we'll check for the count which is being stored at that particular point, and we'll add that to our praising word, and like this only we would be able to fill up count of the longest chain corresponding to that particular word. So this is the thing in which we are not even required to sort, right? But because of DFS only, and by memoizing it, here memoization takes place due to the set and hash map only, basically hash set and hash map only, which we call as unordered set and unordered map in C++. So because of these two things only, we are able to memoize our DFS solution, and because of DFS only, we are not required to do sorting in this particular question, and due to that, we are able to reduce our time complexity. So that's why this is that particular solution which will work here in the best possible manner. So now I'll show you how to code this particular solution, but before that I just want to explain you with the LIS solution also, because LIS is the standard one, right? So that's why I hadn't drawn much diagrams and so on. I guess I had already explained the solution also with its recursive and even its memoise and bottom up and even its binary search solution also. That's why I don't want to explain it again. But yeah, I'll show you the code because yeah, modifications are required as per this question. So here we are required to sort an increasing order of length, which will take us n log n time. So because of this, when we'll sort it, then only we can perform LIS on the same. So that's the thing. Now, then perform LIS, but here we need to add one more mandatory condition as per the question, because in the question it is required that, see, if whenever we performed LIS, then it was simply on the integers, right? And in that we were checking that if the present number which is there, is it greater than the previous one or not? How much greater it is, we were not concerned. But here, we are concerned about the length, that the length difference should be 1 between the two words. So this is the mandatory condition which we are required to add in that particular both of the words, and then else we won't add that particular to that LIS array. That is the concern we are having here while performing the LIS. But how I have modified this particular question solution is, like, I would be not directly applying LIS here. What I would be doing is that this particular thing of this difference between length of the two words should be 1. This is I'm fulfilling by this thing by taking substrings and then obsoleting one letter each time and then checking the existence in the hash map for the same. So like this I would be performing on this particular question, but here the time complexity of doing this particular operation would be again n into L time only, that time which I was taking while doing that previous DFS plus memoization question. And only extra thing which is being added here is that here I will sort the input array as per the length by, and that would create the n log n solution. Basically additional n log n solution. So now you one thing this is missing, that here the space complexity, that would be order of n, where n would be the numbers which are being stored in the unordered map or set, whatever we would be using. So that's why here also space complexity is order of n, and here also the space complexity is order of n only. The thing is, here order of n is because of two things. One thing is due to the recursive stack, because it is a DFS solution which we are using, and even if it is iterative or iterative DFS or recursive DFS, in both cases that stack would be having order of n only. And then map don't have that much. Yeah, map also have, I guess, because we would be adding up whenever we encounter a new word, right? And there are a lot of possibility of those words, and even okay, so yeah, order of n because of this unordered set only. Unordered map although would be having more words than the unordered unordered set, but still because of the fact that it is only 16, means the length of the word is only 16 at the most. So in that context won't contribute much in as comparison to this particular number of words which are being given, which is in actual 1000, right? So that's why the needed space complexity is because of this unordered set and recursive stack only. So now let me show you the solution for this particular question. Yeah. So I'll first show you with the top-down DP plus DFS, basically DFS plus memoization. Okay. I'm just trying to make it means more of the part is visible. That's what I'm trying. Let us start this. Okay. So here the thing is, this is the main function which is being there. So I am taking this unordered map counts where I would be storing all the counts which would be there for a particular word, and this unordered set where I'll put all the words of this particular vector of string. Now filling up that particular unordered set, then at the starting answer is 0, and just initializing it so that no garbage value is there. And then for const string and word in this words, what I'm doing is basically this is a portion for performing DFS over each word. So from here only we get the time complexity n into, and further the operation which would be done L into L would be because of this Dfs only. So that is the thing. Now, yeah, we delete it also. So here I'm taking maximum if my present is maximum, or if what I get from this is maximum. So this is what I'm doing here now. Now in this Dfs method, that is not right. So now in this Dfs method, what I'm trying to do is, now first thing, that if my count.count current word exists, then I'll return this particular. Just for the fact means there would be various sub problems in this particular Dfs, right? So I need to return that particular at that moment when I find it. So that's what I'm doing here. And then my maximum length would be 1. Why it would be 1? Because even if I'm just having one word, now basically one letter, that is A or B or any out of A to Z letters, then that also contribute to our length as 1. Now comes this particular part. Now here we are doing our main Dfs. So the thing is that here we are traversing our word, our present word, which is being given to us, and how we are traversing by creating a new word each time by taking the substring from 0 to I, basically till that particular index, and then here we have obsoleted one word because here we are taking I plus 1, right? So the word is not word, but basically that particular letter is now obsoleted, and it is starting from the I plus 1 till the end of the word. So now here a new word has been created, and that new word is being checked in this particular word, which was words.count new word. Now it is being checked in this particular unordered set, which is being here, this one, in which we had already filled, right? Now the thing is, we'll update our current length. How we would be updating the thing which I had explained earlier, that it will update because we have found that word, right? So we will add 1 to it, and then we will add by doing Dfs by sending this particular word, then count, and then new word, right? And then the max length equals to maximum of max length and current length. This would be the thing which we will be doing here. Now comes the part, this counts of current word equals to max length, right? So here we are updating, basically here we would be filling the maximum length which has been obtained till now, because if it was A, then it was 1 only, it was B, it was again 1 only, but if it was AB, then the maximum length was 2, which was because of 1 plus A or 1 plus B, right? So out of these also, it will only take the maximum one, although both are having the same 2 only, but still, if there was some other case, then it would have taken out of them. So that's why when it will backtrack, then it will update this particular for that particular word, and then it will return the maximum length for that particular word, and then it returns the maximum length for that particular word, right? So the pointer comes again to this particular loop only, right? And when it comes to this particular loop, now we are having another word waiting in the words vector of string, so that particular would be checked again, and this process will keep on repeating, and then we'll get a final answer. So this is all for this particular Dfs plus memoization. Now let us check for the analysis one. This is the most concise, and even although the time complexity is much more than the previous one, but this one is somehow much more intuitive than that particular, because it is somehow derived from Li solution. Here the only thing is that we'll sort it according to the length, right? So that's with a Boolean comparator just being created, then we are sorting it, and then we have taken this unordered string in DP, basically the map where string int d is there, and this is d which we are taking here, so the word and count would be there, and this only we will be storing the count of each word which is being created, right? And then result which we will be returning at the end by checking for what is the maximum out of both. Now here we are traversing each word. Basically here we are checking for each word in that word vector of string. And when we check for that particular word, then we are traversing its whole length. Again we are creating a new word, same as we were creating in that top-down plus memoise solution. But here is the catch, means the main point is here that DP word which is being there, what we will be doing, we'll find out maximum out of this DP word and we'll check if the DP dot count new word, basically if we are able to find that new word in this particular DP, right, then what we'll do is we'll directly add this one to whatever was previously stored at that particular point, and then this would be assigned to this DP of word. This is the thing which we are doing. Else, if we don't found that particular new word in our DP, right, then we'll directly assign one to that particular word. This is the thing we would be doing at this particular point. So this is the thing which we will be doing in this particular LIS solution, although it is not exact LIS, just a derived version, because if it was half in LIS, then somehow it is different, just a variation. So time complexity is basically n into log n plus this. So the thing is that n log n is basically due to sorting, and n into L into L, because we are learning L square loop. Basically this is there for n words, for this n words, and here we are running L square loop, and that is in this context that each time what we are doing is that we are basically checking for all the words in order of one time, but this substring is all are there, and even a checking part and so on, which directly result in this L square solution with combined with this n, and then space complexity is order of n because of this only, and then at the end we are requiring this result, returning this result. So this was all for this particular question. If you have any doubt, you could comment that down. So this was all. Thank you.